All right, guys. So the last video, we talked a little bit about the concepts of force equaling mass times acceleration. And we talked about how we should know by now, of course, when you were young, you knew this, that the larger an object is, the harder it is to get it to move. So the more force we're going to have to apply to it in order to get it to accelerate. And remember, acceleration is any change in motion. So this video is really just to talk about how we mathematically calculate that and how we can manipulate the formula to calculate different things. Because you may be asked questions and given the mass and acceleration, and you have to find the force right here, looking for force. Sometimes they may give you the force and the acceleration, and they want you to find the mass of the object. And sometimes they may be giving you the force and the mass and ask you to look for the acceleration of an object. So we have this triangle here that kind of helps us with that. So depending on what you're looking for, you have to cover it up. So if you want to find force, then if you cover up the F, you're left with mass times acceleration. If you're looking for mass and you cover up mass, you're left with force divided by acceleration. And if you're looking for acceleration and you cover up the A, you're left with force is divided by mass. Okay, so we're going to use this triangle to help us understand how to manipulate the formula to answer some questions. So let's go through some sample questions so you understand what you'll have to do. Okay, so a golfer hits a golf ball with a club. The mass of the ball is 0.05 kilograms. So that means right here, we're going to type in, I've got to get out of present mode, sorry. So right here in the mass, we're going to type in 0.05. Okay. The ball accelerates at 2,000 meters per second squared. So here for acceleration, we're going to put in 2,000. Okay. So in order to calculate it, we can take this number and drag it over here because that's the acceleration. Okay. We can take the mass and put it over here, the same color box, and put it right there. And then if we do this calculation, 2,000 times 0.05, what we get is 100 newtons. Okay. Now, I put a link down here to a Desmos online calculator that you all need to get used to using. It is the one that's going to you'll be allowed to use on the STAR test. Okay. So the force here is going to be 100 newtons. So if I can just copy and paste that box and put it there. Okay. So that's calculating force given the mass and the acceleration. Okay. So that's pretty straightforward. That's what the formula basically says. Now, what if they don't give you the same information? So here, a basketball with a mass of 0.60 kilograms. So down here in the mass box, we're going to type in 0.60. Is accelerated with a force of 10.8 newtons. So the force here is going to be 10.8. Okay, and they want to know what is the acceleration of the basketball to the nearest meters per second squared. So if we drag these over into the appropriate box, okay, sorry, I got to change the order here. There we go. So now this is kind of odd. So we need to know what number here. So we have to this is where we have to manipulate that formula. So we have to get the unknown by itself on the one side of the equal sign. So we would divide this side by 0.60 to get it alone, okay, to cancel out the 0.60. And if we do something on this side, we have to do it on this side. So this would end up being 10.8 divided by 0.60. So again, we're looking for acceleration. So if we cover up the A, the way we figure out the answer is force divided by mass. Okay, so we can go to the Desmos calculator and we can type in the force 10.8. Okay, and we're going to divide that by the mass, which is 0.60. Okay, and we get an answer of 18. Okay? So that would mean that the acceleration of this box would be 18 meters per second squared. Okay, and then again, reminder about how to change this text now to a superscript to get 18 meters per second squared. Okay, and then what happens if they give you the force and the acceleration? So a shopping cart is pushed with a force of 144 newtons down the aisle at HEB. So we're going to put in 144 newtons of force. It accelerated at 12 meters per second squared. Okay, so just to kind of make it easy, we can just copy and paste that information right in there. So we're going to grab this one over here and again change the order. Sorry. And then we're going to take the acceleration and we're going to put it over here. And so now we're looking for the mass. So the same way we did the last problem, I would divide this side by 12 to get rid of it, to leave this by itself. But if I do it on this side, I have to do it on this side. And so here is going to be 144 divided by 12. Okay, so we're looking for mass. So if we cover up the m here, it's force divided by acceleration. And so again, 144 divided by 12 gives us a mass of 12 kilograms. All right, so hopefully this helps. Again, we're going to be having a lot of practice with this, and make sure that you use a calculator. We don't want the calculation piece to mess up what you should understand as a conceptual piece. All right, guys.